Let's take a quick look at the week 7 lesson 4, I guess part 2. We just want to take a look at how we fit a 2 Gaussian peak model. So in this one, remember, I want to fit this green data set. This is the data that was actually taken, and I want to fit that to 2 overlapping Gaussians. The authors of the paper show the 2 overlapping Gaussians, P1 and P2, that they used for the fit. So we're going to go ahead and pull those off as well so that we can add those together and see how that compares to the green curve here, this thick curve, which is actually, again, the data. So first thing we're going to do is we'll just pull in our select data function and our calibrate function. So hopefully we have both of those already. And then what I would do is I would run So it looks like I'm having some kind of problem with the output here. You can see I'm not getting my plot. I'm not getting any error messages. So I think it's something to do with this showing up on the screen to be interactive. So what I'm going to do is I'm going to go ahead and close down the notebook and reopen it and see if that helps. Okay, so I've restarted the notebook. I actually had my kernel open from a day or two ago. So I just wanted to open up a fresh kernel. So here we are. Let's see how that works. So I've gone in, I've run my functions, select and cal, and then I'm going to go ahead and run my select points. There we go. All right, so it's back. So if you get any kind of weird thing like that, just close your notebook and also close the kernel so that you're starting out completely fresh. All right, but for this problem, what I would do is I'd come in here and I'd select points. I'm just giving you an idea, running it really fast here. All right, I'd select some set of points, and then what I would do is I would run pixel positions so I could see them. So there they are. And then I'd copy this and I'd paste it into, in that case, DSC data. So what I'm going to do is, instead of writing this line of code over and over again, I'm just going to keep rerunning it and selecting a new set of points, copying them, and I'm doing this manually, so I'm just doing a copy and then a paste. Okay, this is the data that when I did this carefully, that I got for the DSC data. That's the green curve here. And then I'm going to do it for P1 and P2. Right, so again, the idea would be as I just simply run this part, and then I could go through here maybe and select, right, some points for P1, and then I would run this so I could see them. This is what I selected now, and then I take and copy and paste that into my variable for P1. I call this P1 author data. Okay. And then I do that again to get P2. So that would be my 3 sets of curves. The other thing I'm going to need is my calibration. So I would, again, just run this. And now I would pick off my 3 points like that. And I'm going to pick this little tick mark there. Okay. So again, I'll run pixel positions. There's my 3 points I picked. I would put those, paste those in here. And then I would include my plot points. Right, so I picked 800, 0, I picked 25, 0, and then I picked 25, and then I called this 1. So this is an arbitrary scale, so I just called it 1 up here. You could pick this one and call it 1, or that one, whichever one you like. But now I've got everything I need, and now if I mess up, I don't have to keep rerunning all of these select data. I now have the data that I did once, so I can skip those steps like I'm going to do here now. So now I'm going to run these. Now all my data is in there, and so all I have to do is go ahead and plot it. And there's my data reproduced. Okay, so I've called my data, well, I have to calibrate it. So my blue here's the DSC data, the experimental data. Right, I calibrate it by giving it pixel points, plot points, and then the data I want to calibrate. And then I do the same for my P1 author data, P2 author data, and I'm going to call these cal P1 author, cal P2 author for calibrated. And that's what I'm plotting here then, right? My X, my Y, blue, point. P1 is green, P2 here. I'm using a different format here so I can use dark orange. I wanted orange and I don't have a code for orange. So I'm going to go ahead and use color. These are fun because there's tons of colors to pick from. All right, and then I can tell it whatever marker I want to use there. All right, so that's just another way to do that. Now I have my data set and I want to go ahead and fit it with 2 Gaussians. So I'm going to do several things in this homework. One is I'm going to fit the P1 and P2 data separately. When I fit those, that needs to be a single Gaussian fit, right? It's just one peak. I want those because that's the author's fit. So I want an equation for the green and the orange curve, which they didn't give. And then once I get these two, I can add them together and then compare to the blue data points to see how well their fit really was. We can also fit now the blue directly ourselves with 2 Gaussians and see how our fit compares to these 2 peaks that they used. All right, so but I have all my data, and now I just need to focus in on the fitting. Okay, so let's go ahead and take a look at the fitting routine. So this particular fitting routine is going to use the package lmfit. Okay, so I did call that in somewhere up here. I haven't called it in yet, so I'm going to get an error. There it is. Doesn't like this. Okay, so I must have originally called it in way back up here, which I didn't actually run for this video for the lesson. So here's what I haven't done yet. So let's go ahead and do that. Let's make sure that we have this SciPy in there as well. I don't remember if I included that. All right, so I'm going to scroll back down, and there's my data set. There's my fit, and I'm going to go ahead and put a line in here and make sure that I do import the lmfit routine. Okay, so there it is. So let's go ahead and run this, make sure things are going to work. And now let's go ahead and look at it. All right, so the first thing I need to do in this lmfit, if I'm going to fit a set of data, is I need a model. And that model can be anything. This could be just a linear model, y equals mx plus b. It could be a polynomial, it could be anything. In this case, the model is a Gaussian, and we've defined it ourselves. So this Gaussian I just called G. That's the name, so that goes in here. This Gaussian takes some x data that I'll define, and then it fits an amplitude, a mean, and a standard deviation to it. And so here, if I put these values in, this is going to return the Gaussian formula. And so we've got everything in there, and the variables are all defined. So now with this problem, if that's all I was going to do, then I'd only need one model to fit P1, one model to fit P2. Okay. We're going to go ahead and write the blue curve, which has 2 overlapping Gaussians in it. And so that's why I'm defining what I'm calling 2 models here. It's 2 part of the model I'm going to use. So part 1 corresponds to the first Gaussian, right? And I'm just using my function Gaussian. Then to distinguish between the variables a, mu, and sigma, in this fit, I'm going to put a prefix on them of m1 underscore. Okay. So that means I'd have m1 underscore a, m1 underscore mu, m1 underscore sigma. And then my second Gaussian I'm going to fit to same function. I'm going to call that model 2 or part 2, and the prefix here then is m2 underscore. And so that would be the variables for that particular function. And then we're just going to add these two together. And so that would be two overlapping Gaussians in our overall model. Okay, so in the lmfit routine, we also need to define our parameters that we're going to use in this fit. So we need to make sure we define A, mu, and sigma in this case. And so this is done by the parameters add many command. So here I'm just setting it up and telling it to expect parameters. This is from the lmfit routine. Okay. And then to this params now, I'm going to add all of the parameters that are in my system of importance. Right. So I got to go ahead and define my m1 a mu sigma and my m2 a mu sigma. And the first value I've got here is the initial value. So this says value here. Probably should just make that clear. This is the initial value, the initial guess that the fitting routine uses. The second place here is whether to vary this parameter or not. So you could, if you want it, put false somewhere, and that would fix one of the parameters. It would not use it as a free variable. Okay, so we have true in all these because we want to change these values and actually fit. All right, and then if you want, you can define a minimum and maximum range over which that value is allowed to extend. And then there's some other ones. I'm just going to not worry about these for now. You can do some pretty fancy expression writing for relating one variable to another if that's appropriate, and you can even tell it what kind of steps to use in the fitting. Okay. We're mainly going to use just the initial and the min-max in some cases. All right, but these are the default values to put in, and then you define yourself. Go ahead and define the initial. All right, so now that our parameters and our model are defined, and these steps are always done, just like we have here for whatever function you have, then we can go ahead and define our x and y data that we're actually going to go ahead and fit. Right? In this case, we're going to fit this blue curve, which is in Cal DSC. Right? And so that's what we're doing here. I'm saying my x value is Cal DSC, pulling off the x values, Cal DSC pulling off the y values. So I've got my x and y data, and then I'm going to go ahead and do the fit, and that's done with this one command. So we use, here is the model, so we're telling it what model we're using. That's where we've defined it here. And then applied to that model is the fit. This is the fitting routine. The fitting routine is the y values are given first in the fitting routine. The parameters are defined as we did up here, so we just pass params. And then the x values have to be given as well. And so to define those, we just have x equals, so we're telling it that we're defining the x values. And in our case, we called that x. So if that's confusing, I could have called this x data and then x equals x data. Okay, so it doesn't look like we're doing something weird there. So it's just telling it what the x data is. So this x equals is always there, and then you give it the x data. All right, in this case, since I've got two terms in one model, I can use this components command, which it will take the result that we get here and it will evaluate the components, meaning it's going to give us these individual fits and let us know what those are. That's what that stands for. All right, that's really it in terms of the fit. So it's all really this one step. Everything else is just setting up. So we'll go ahead and plot it. We'll plot our x and y data, which I changed this to x data now. We will plot the result best fit. So this is going to be our best fit points that are already built into the model in the output. And so that's y data. So here's our x data again. And then from this components, this comps, it's going to have two sets of data for us. The first set is the prefix M1, and the second is the prefix M2. So that's what those are. So it's going to pull those individual ones out, peak 1 and peak 2. Again, I changed my X, so I'm going to have to change these. Okay. Then we've got our labels in black and green. We'll put a legend on it. We'll put it, the location for the legend will be wherever it best fits, so it's not overlapping on our data. And then we'll go ahead and show it. And then one more thing we'll do is in result, also, if we do best values, it'll give us out these fitting numbers in the final fit. So best fit is data to plot. Best values is the values of A, mu, and sigma. So let me go ahead and run that. And there we go. So notice here's the printout, best values. So we can see what we had for each variable. You can see now how the variables have their prefix in front of them for the individual peaks. The blue curve is just our XY data that was fit, right? Those are our data points. The red is our best fit, okay, which is simply a sum of P1 and P2. Okay? And then P1 and P2, we could plot ourselves now that we know A, mu, and sigma for them. We could just use our function G and just plot these. But that's our fit, and hopefully you can notice right away that it's quite different than theirs. This peak is a lot smaller in our fit. So we'll take a look in the next video at comparing these two to our two and to our overall fit and see what's going on here. So let me stop right there.